Hello, welcome to a Python tutorial. Today we're going to be making a video game. And so what game we're going to be making? Let me show you a little example of what we'll have by the end of this video. Alright, so if I run the code here, you'll see this little window pop up and we can collect things, all fine and dandy. We have little sound effects, we have a score to keep track of how we're doing, we have our player moving here, all pretty cool stuff. So why learn how to make a game in Python? Well, there are a ton of benefits. For one, in this tutorial alone, you'll learn all these concepts: variables, functions, loops, conditionals, a bit of object-oriented programming, a bit of graphics programming concepts, some game dev concepts, some code management concepts, learning how to use relative file paths, and also just adding another way to have fun with coding, because having fun coding is one of the most important things you can do, especially when starting out. So with all of these things said, let's go ahead and get started. So if you don't have your development environment and all that stuff set up, let's go ahead and get into it. If not, you can skip to this timestamp on the screen. First thing you're going to want to do is go to python.org, and here you're going to want to download Python. And so I'm going to go to the downloads here. If you're on Windows, just click this button here. If you're not, you can go to macOS or other platforms and just download the latest release. Download it and you're done. Next thing you want to do is download an editor, because you need to actually be able to write your Python code somewhere. And so for this, I'm going to download Visual Studio Code. So I'm going to type in Visual Studio Code and then just go to the very first link and download it. Download it for the platform that is for you, of course. And then just run the setup and you're all set. All right, so when you open up Visual Studio Code, you should be greeted with this screen here. This is just your little starter screen. And from this, we're going to be creating a new project. So here I'm going to click on Open Folder, and then I'm going to navigate to the folder that I want my project to be in. So whatever folder you open it in is the folder that your project is actually going to be in. So I highly discourage just like dropping it, opening your desktop folder and making your project there, because then your project files are just going to be sprawled all along your desktop, and that's not very organized. I'd recommend making a dedicated folder for this and putting all of your project files inside of there. So just select a folder that you want and then select folder. And then if it works, if you see this, the name of your folder at the top here. So if I expand this a bit, you'll see that I have the name of my folder, Apple Game here. And you'll see that I also have this assets here. And this is something that I have linked in the description. This is going to contain all of the assets inside of our game here. And all you got to do to import this is you simply go to the assets that you have and just drag and drop them here and just copy the folder. I already have it, so I'm not going to replace there, but just drag and drop and you should be good. And what you'll notice is that if you right click on it and then do reveal in File Explorer or reveal in Finder for macOS, you'll see that the file is physically inside of the folder that you created. So now that we have this, let's go ahead and create our first Python file. This is where we're going to be writing our code. So I'm going to go to the start here and do new file, and I'm going to title this main.py. It's just traditional to make your first file called main.py, and you want to make sure this is in the actual root directory. So I'm going to move mine here out into the root directory. You'll notice that if you close your assets here, and if it's still there, that means it's not inside your assets. So just make sure it's in the root here. And now we want to actually use Pygame, and Pygame is a library that we are going to be using for creating a window, drawing graphics, all that sort of stuff. It basically makes it a lot easier to develop games. And so for this, we're going to be opening the terminal and installing Pygame. So for this, we can do control backtick, which backtick is just below the escape key. And this opens up our terminal in VS Code. And you just want to do pip install Pygame. And for you, it's going to do a ton of different downloading stuff. But for me, since I already have it, it is going to say requirement already satisfied. But as long as it installs properly, that should be good. For Mac OS users, I believe it is pip3 install Pygame. And if neither of those work, there are a lot of ways to troubleshoot this. I have linked in the description, because pip can be broken at times. So just get that all fixed and get Pygame installed and you should be good to go. So now with that, let's go ahead and close our terminal by pressing control backtick again to open up some space. And I'm also going to close the Explorer here with control B just to give us the most amount of room here. And I'm going to start coding. So how are we going to get Pygame into our main file? Well, it's really easy. All you do is you do import Pygame, and this will import Pygame into our main file. And so now what we need to do is we actually need to start Pygame up. And the way we do that is by doing a function here. We're going to do pygame.init, and this init means initialize. And all we're doing here is we are basically starting up Pygame. That's what we need just to get all the background stuff up and running. Next thing we need to do is we need to actually create a screen to draw on. And so for this, we're going to create a variable. And the way we create a variable in Python is we do screen, or whatever you want to call your variable. I'm just calling it screen, and then do an equal sign. And then we can do pygame.display.setMode, and this is a function here, and this function takes in at minimum one argument here for the size, and for our size we're going to do a size of 350 by 600, and it takes it in as the form of a tuple, and a tuple is just a data structure that stores multiple values. So for this we're going to do parentheses here inside of these parentheses, and for the width we're going to do 350 comma, and for the height we're going to do 600. I will note that spaces do not matter. If you're a complete beginner to Python and you're worried about spaces, don't worry, you can put a million spaces, it does not matter. The only thing that does matter is indentation, but we will get to that in a bit. So now we have a screen. So now if we were to run this by pressing F5 or by going to run and start debugging and click Python file, you will see that we have a screen pop up, but it immediately disappears. And this is because Pygame has created the screen, but there's nothing keeping it open. We have to actually keep our screen open for as long as we want to be able to keep it from not just disappearing on us. And so for this, we can accomplish this by creating what's known as a game loop. And a game loop is just a loop that loops over every single frame and does all the sort of updating and drawing and all that sort of stuff that's required in a game. For this, we can do what's known as a while loop in Python. I'm going to make a comment here to do a bit of organization. I'm going to do Control/ to create a comment, and I'm going to call this our game loop. And then below it, I will start this game loop here. I'm going to do while, and then we need a condition here. We need a condition that can be true. So let's go above here and let's create a condition. We'll create a Boolean variable, and a Boolean variable can basically only be true or false, which is very useful in a while loop. We will do running equals true. And then basically what we'll do here is we'll do while running and then colon. And now all we'll have to do is we'll do pygame.display.update. And here is where that indentation I was talking about comes in. So in this while loop here, everything indented over is now inside of this while loop. So if I was actually to put something below this, like hello equals hello here, this is not in this while loop. We are not doing this inside. We're doing this outside after the while loop. Once we exit this indentation, we are no longer inside this while loop. And this works for as many as you want. You can do a while loop here, and then hello equals hello. And now this while loop is in all three of these. Of course, we don't want to do that, so let's just go ahead and get rid of that. But that's how indentation works in Python. So now there's one more thing we have to do. Do not run this because there's actually no way to close your screen once you run it. And the reason is because we don't have anything set up to capture when the user wants to exit the screen. Right now, all we're doing is we're opening a screen and we are simply updating it every frame. But what we need to do is we need to gather the events and check if the user wants to quit. And if they do, then just quit the game. So for this, we're going to do this. We're going to create a for loop. This is going to be for event, or whatever you want to call it, in pygame.event.get. And then we'll do an if statement inside this for loop. Notice how we're indented one over. If event.type equals =pygame .quit, then pygame.quit. And for extra insurance, I'm going to actually import one more little module here. I'm going to import system. This comes with Python itself, so sys here, and we'll do system.exit. This will properly exit us out, just in case. I probably won't need it, but just in case, extra security. So what's going on here? We are basically, what we're doing is for every single frame inside of our while loop here, we are going to gather the events with pygame.event.get. If we hover over this function here, you'll see that this has an arrow to list. This means that this function returns a list of events. So we are getting a list of events here. And what the for loop is doing here is we're saying for event in this list of events, we are looping through every single event for that frame. So let's say I press the A, S, and D key. The events for that frame that I press them on is going to be A, S, and D. Basically what we're doing is we're looping through all of them, and then we're checking for each of them. If that event has the type of a pygame.quit event, then we want to quit. And now we can safely run our program. As you can see, our window is up and running. We can move it around, all that sort of stuff, and we can press X and it closes. And basically what happened there was caught that one of the events was a quit event, executed this code inside of the if statement. Cool. All right, next step. One that's actually pretty important, but you don't really know to do it, is actually setting up an FPS. FPS is kind of wonky in Pygame. It'll just run as fast as it can pretty much. So we want to actually set up what's known as a clock to regulate this. So I'm going to create a new variable up here, clock equals pygame.time.clock. clock. This is creating an object of the clock class. If you hover over it, it'll say class clock. You don't really have to worry about that too much. All you have to do is go down here, and right at the bottom of our game loop here, we will just do clock.tick. And then in here, we need the frame rate that we want it to be at, which will be 60 for us. And now if we run it, we'll see absolutely nothing, but this will be important down the line. Now let's go ahead and draw our background here. And for this, I'm going to show a new concept, or not a new concept, but another one of those concepts that I said we're going to cover. We're going to create a draw function here. And this is just for organizational purposes, but we're going to create a new function. And the way we create a new function is we use the def keyword in the beginning. So we're going to do define here. So it's def, and I'm doing it above the while loop here. And we're going to do def draw. And then the way to properly make this a function is by doing the parentheses after the name of the function, and then do a colon here. And the colon, you'll see that you immediately get an error on the while loop. This is because a function cannot be empty. Anything like a while loop, for loop, function, if statement, anything that requires things to be indented on the next line, it has to have something. Now, if you don't have anything to put in it for now, like you're just making the scaffolding, you can literally just put pass here and it will pass it and that error will go away. But we do actually want to do something here. We want to draw to the screen. And for this, we're going to do screen.fill. And here we can send in a color value. There's a ton of different color values. You can do RGB values and all that stuff. I'm just going to use a built-in Python value here, or not Python, a built-in Pygame value here. And this takes in a string. So I'm going to do quotes, and I'm going to do light blue because it's the closest to sky. Now we're going to actually use this draw method inside of our while loop here. And we're going to go down here, make sure that we are outside of this for loop here. We want to be inside of only the while loop. So we want to be outside of these indentations and just make a call to the draw method with draw parentheses. Now what this is doing is while it's running every single frame, it's going to see this draw call. It's going to go up to the draw method and execute everything inside of here, and then return and keep doing its business for the rest of this while loop, and just repeat that every single frame. So now if we run it, you'll see that our screen is now light blue. Pretty cool stuff. So the next thing we want to do is we want to import an image. For this, let's go ahead and reopen up our tree with Control B here, not our tree, our Explorer, my apologies. And now we have this assets, and we're going to click the drop down here, and let's go to our player. So this is our player image here. And let's analyze some stuff about this. One, its name is player static, cool. And another, its size, the ratio, the width is a 1:2 ratio with the width and the height. That'll be useful for scaling. So let's go ahead and create our image. For this, I'm going to just create a little space here, and I'm going to make a new comment for organizational purposes and call it player. And then I'm going to create a new variable, and I'm going to do player_image equals pygame.image.load. And here, this function here takes in, for the first argument, it takes in the file argument here. And so for this, I'm going to do quotes because it's a string value. And now this uses relative file paths, and these file paths are relative to our working directory. Our working directory is the folder that we are inside of. So for me, that is this Apple game folder. So since we are already in it, we don't have to specify to look in it. We instead have to just use whatever other files are in here. So since our player static is located inside of the assets folder here, what we're going to do is we're going to do assets / and then player_static.png. Then at the very end, we're going to do .convert alpha. Don't worry too much about this. Basically what this does is it simply optimizes the images in Pygame. So whenever you import an image in Pygame, just make sure to do this .convert alpha at the end. It just makes it run a lot faster. Cool. So let's go ahead and just get this drawn on our screen so we can see some progress. For this, I'm going to go into our draw method because we want to do all of our drawing inside of our draw method here. I'm going to do screen.blit, and I'm going to take this player image, and then it takes one more coordinate or one more argument here. So I'm going to do a comma to send in a second argument to this method here, and this argument is a coordinate. And much like the pygame.display.setMode, it takes in a tuple, but instead of a width and a height, it takes in an x and a y. And here we have to get into how Pygame does coordinates. So if we go here, you'll see that the coordinate system is a little bit flipped from how we normally think of it, where the bottom left is 0, 0. Actually, the top left is 0, 0 for Pygame. And by default, we address things by the top left coordinate of their surface area. So knowing this, we can make our coordinate appropriately. Now, since it's 350 and 600, I'm just going to put it for now in the center of our screen. So I'm going to do 175, 300. And if we run this with F5 or start debugging, then you'll see that we have our player, but you might not actually see it because it's super tiny. And the reason is because the image is actually 8 pixels by 16 pixels, and it is literally 8 pixels by 16 pixels on our screen. So that, depending on your screen resolution, could be absolutely microscopic. So for this, we're going to actually rescale it to a reasonable size here. So I'm going to go to our player and I'm going to do this. I'm going to do player image equals pygame.transform.scale. This takes in, for the first argument of this scale function here, we need the image that we want to scale. So we're going to do player image, and then for the second one, it's going to be a tuple, which is the width and the height that we want to scale it to. And for this, it is highly recommended to create a constant scale value. For this, I'm going to actually create a tile size. For example, like Minecraft has a fixed size for all of its blocks, and this is sort of like a constant that they use, where like each block is 1 meter by 1 meter. So we're just going to basically replicate that in a 2D plane. I'm going to create a new comment and call it constants, and I'm going to use the constant convention of all uppercase and create our tile size here. There is no actual way to make a constant unchangeable variable. However, in Python code, if you encounter a variable that is all caps, it basically means, hey, don't touch this. That's just the accepted convention by the community. So now, given that our player image here has a size ratio of 1 to 2 by the width and the height, we are going to scale it appropriately. So for the width, we will do tile size. For the height, we'll do tile size times 2. This will now make our player 32 wide by 64 tall. And now if we run this, we now see that our player is reasonably sized. So now with this, we can do some more stuff. Let's actually draw the floor. So for the floor, I'm just going to go ahead and go above the player here, and I'm going to create a new comment. I'm going to call this our floor, and I'm going to do this exact same thing. So I'm going to go a little bit faster now because we're just doing the same thing. So floor image equals pygame.image.load, and then assets/floor.png.convert alpha. And then we want to actually scale it because remember, they're a little bit messed up here. So I'm going to do floor image equals pygame.transform.scale. And this is going to take in the floor image as the thing we want to scale. And then for this, it's actually tile size times 15 and tile size times 5. Now what we can do is we can actually draw the floor here. So we can do screen.blitz, and we will do the floor image, and we will do just a random value here. I guess I'll just do like 100, 0, or 0, 100, and we'll draw it here. And you can see that we have our floor. It's in the wrong spot though. And for this, the way we're going to solve it is we're going to be using a data structure known as a rect in Pygame. The rect data structure is really powerful because it is used for a million different things. It's used for collisions. It's also used for positions. It's used for getting different facts like the width and the height and the center of an object, stuff like that. Very useful stuff. And the pygame.rect is broken down into basically this. So we have our actual rect, which is just a rectangle. And from this, we are going to have the X and the Y, which are here. The X and the Y, they're in the top left corner. Then we also have the left, the right, the top, the bottom. These are all accessible values that you can use if you create a rect. We also have the center. These are all, and then we also have the bottom left here, and then we have the bottom right here, and then we have the top right here, and we have the top left. That's the same thing as this. So as you can see, using a rect is very useful when you're trying to position, move, check for collisions, all that sort of stuff. It's really useful to create this, and it's also really easy to create one. So what we can do here is we can create a rect for our floor, and for this we'll just do floor_rect, and this is going to just do floor image.get rect. And for this, we can just leave it as B and just get the rect of it and just place it wherever we want, or we can place an initial position for our rect. And for this, I'm actually going to do bottom left equals, I'm going to do 0, comma, and then I'm going to do the height of the screen. So screen.get height. And remember before that the bottom of the screen is actually the height of the screen in pixels. So if we put the bottom of our floor at that position, then we will find that our floor will be at that position. However, if we run this, we will see that absolutely nothing changed because we are just drawing our image at the specified coordinates that we put here, 0, 100. This is because our image is not associated with our rect. However, here, all we have to do is instead of putting this here, we can just get rid of that and just do our floor rect. And what this is going to actually do is it's going to take the X and the Y value of our floor rect, and it's going to use those instead of a hard-coded value. So now what we can do is we can run it, and we'll see that our floor is positioned properly. So now let's position our player properly. And for this, we're gonna have to do a little bit of math gymnastics here. I'm gonna create a rect for our player, and I'm gonna do player underscore rect equals, and then it's going to be player image dot get rect. And for this, I'm going to do the center because I want to actually center it. This is going to be equal to a tuple value. For the width, we want we want the center of the player to be at half the width of the screen. So we're going to do screen dot get width divided by 2. And then for the height value here, what we want to do is we want to start at the bottom, go up the amount of the floor, and then go up half the player, and that will put the center of the player at the proper position. So for this, we'll do screen dot get height, and then we will subtract floor image dot get height, putting us where the center of the player is at the top of the floor. Then we just want to move it up half of the player's height so that we are in the proper spot, so the feet of the player are touching the ground. So we will do minus in parentheses so that we don't have any PEMDAS mumbo jumbo going on here. And then we'll do player image dot get height parentheses, and then we want to do divided by 2 here. So we are subtracting half of the player's height. So we're getting the screen height, subtracting the floor height, and then subtracting half of the player's height. And that is all for the Y value of our player. Now, if we replace the values that we put here for our player with the player rect, and we run it, you will see that the player is standing on our floor perfectly fine. Cool. Now let's get our player to move around. For this, I'm going to create a new function here, and this function is going to be called update. So I'm going to do define update parentheses, and then do colon. And here, what I'm going to do is I'm going to get input, but I'm going to get it a little bit different than here where we're looping over the events in pygame.event.get. I want to check if buttons are being held down. And the way we're going to do that is we're going to do keys. I'm going to create a new variable called keys. I'm going to set it equal to pygame.key.getPress. And now all we have to do is this is actually equal to different inputs of that current frame. So what we're going to do is we're going to do if keys, and then we're going to search for it in here. And so this keys is going to be a dictionary, and this dictionary is going to have, so the way to check if we have a key being held down using this keys variable here is we're going to check if keys, and then in brackets, we're going to put the key that we want. And for keys in Pygame, you start it with the Pygame, and then you do dot, and then for most of them, you do K underscore. So I'm going to do K underscore left, and this is the left arrow key. So if we press, or if we're holding down the left arrow key, we want to move left, right? So how are we going to do that? Well, we're going to change the X value of our player rect, right? So what we're going to do here is we're going to do inside of the if statement. So make sure that we are tabbed over one. We will do player rect dot X, because remember it has all these accessible values here. So we're addressing this X value, player rect dot X minus equals, and I'm going to put 8. You can put whatever speed you want, of course, but now we have this cool thing here. And then just make sure that inside of your while loop, we want to actually run this update function every single frame. So we are going to make a call to the update function. And it's recommended to put the update function below or above the draw method or draw function to be called before. It doesn't really matter too much though. So you can just run this here. Now you can see if you press left, we are moving the player. So cool. Let's go ahead and add our right key. So I'm going to highlight this and then do Shift Alt down. And this will just copy that code below. And I'm just going to change this to K underscore right for the right key. And I'm going to change this to a plus equals. Now we can go ahead and run our code here, press F5. And now we can move around our little player here, which is pretty cool. So now let's create some apples. So for this, we're going to have to import our apple images here. So let's go ahead and do that. I'm going to create a new section here, and I'm going to call this apple section, just with a comment here. And I'm going to do apple underscore apple underscore image equals pygame.image.load, and then asset slash, and it's called apple.png here, .convert alpha, and then I'm going to scale it again. So apple image equals pygame.transform.scale and apple image, and then for the size, we'll do tile size by tile size. So it'll be 32 by 32. But now we're tempted to just create an apple rect value, right? The same as we did before, apple rects. but we're going to have a lot of apples, right? We're going to have infinite apples. They're going to be spawning all the time. This approach could be considered inefficient. Now, while there definitely are ways to make this possible by using just that simple apple rect, I'm going to be using a different approach that will hopefully teach some more important Python concepts. So for this, we're going to be using the object-oriented programming, as was previously mentioned. For this, it's going to take a bit of explaining. So object-oriented programming is when you work with classes, and think of classes as basically the blueprints that hold different values. For example, let's use humans as an example. I'm a human. You're most likely a human. And humans have some different facts about them. They have their height, they have like their hair color. All these sort of things are different facts about humans. Humans all have these different like attributes about them, but they're all relatively the same. However, there are different values. I have brown hair. Someone else might have blonde hair. I am 6'2". Someone else might have different height. Different things like that. However, we both still have the same attributes, just different values for them. So think of classes as essentially blueprints. Like, this is a human, this is what a human has. What type of that it has, who knows? And so basically, using this analogy, we can kind of hopefully understand what classes are, but it's a little bit easier just to kind of show what they do. So for this, I'm going to create a new class. I'm going to put it up here because I'm going to define it up here so that we can use it down here, because Python's an interpreted language, and if we try to use something before we actually create it, it's not going to know what's going on. It's not going to know it. So we're going to put it at the top pretty much, and we're going to create a new class by calling it same class, and the name of the class, I'm going to call it apple, and then a colon, and it works basically like a for loop or if statement. You have to do everything inside of this class indented. So I'm going to create what's known as the constructor, and this constructor is called whenever you create an object of an apple. So like if you want to create an apple out of this apple blueprint here, it will call this initial constructor. So we'll go do def underscore init. This is a dunder method, a double underscore method. This requires you to take in the self argument, and then we can do a colon down, and I'm going to pass it for now, meaning that it has nothing in it. So now if we create a new apple object by doing like, let's say apple1 equals apple here, and then do parentheses, we have created an apple object, and what it's going to do is it's going to call this constructor method automatically. Notice how I'm saying method and not function. When this def name parentheses is inside of a class, the function becomes a method. But let's think about what we need inside of our apple class. So what will this apple have? It will have it'll have an image, it'll have a position, and it'll have a speed. Okay, so we just put those in our constructor. And now what you'll see is if we hover over this apple here, we will have these arguments that we need to send it. We need to send it the image, the position, and the speed here. So let's go ahead and basically fill this out. So if we go down to our apples here, and let's create a new apple. So apple1 equals apple. Now it'll say we need an image. So let's do the apple image for that. And then it'll say we need a position. I'm just going to put it at 100, 0. And then it's going to need a speed, and I'm going to put that at 3. So now we've created a proper apple object. We can now use it. However, if we try to do something like apple1.image, we're not going to get any code suggestions or anything. And that's because we haven't actually stored these values. We need to actually store these, because right now this is just an empty class. We're sending it stuff, but it's not doing anything with it. And you'll notice that it's grayed out, and that'll tell you that you're not actually doing anything with it. You can see speed is not accessed Pylance, basically meaning that we are sending it this, but we're not actually using it. So what we're going to do in our constructor is we're going to use it, and we're going to do self.image equals image. But why are we using self? This is meaning that this value is unique to this object. So basically this object image, this apple1's image, could be different than apple2's image. So if we copy this down, do apple2, and send this our player image, now these two apples have different images. So if we were to do apple2.image, we would get a different result than if we did apple1.image, and yet they both still have images. So now let's go ahead and store our position. However, we're not just going to store the raw position, we're going to create a rect out of this position. So the way we're going to do is we're going to do self.rect equals self.image.get underscore rect. In parentheses here, we will do the top left equals position. Now we need to store one more thing, which is the speed. So self.speed equals speed. And now you can see that none of them are grayed out. We now have all these values stored inside of our apple. Cool. So now we can make some apples. I'm not going to just do this here. I'm actually going to create what's known as a list. So I'm going to go here and I'm going to create a new list. I'm going to call it apples. It's going to be equal to brackets to create a new list. And here, this is going to be a list of apples. So I'm going to create one here, creating an apple object. With parentheses, the image is going to be the apple image. And then the position is going to be 100, 0. Speed is going to be 3, comma here. And I'm going to just make another one here. And I'm going to move it over to 300. Cool. Now what we're going to do is in the draw function here, we're going to be drawing all of the apples here. So for this, we're going to use a for loop in the same way that we use one in our while loop here. We are going to, inside of our draw function here, we will do for apple in apples. And then what we'll simply do is we'll do screen.blit apple.image for the first one, and then apple.rect. What this is doing is it's looping through every single apple object in our apples list. Then it is drawing it using the unique image of it, even though they're the same image. And then it's taking the unique rect value. So for the first one, it's going to give us the rect value with 100 and 0 as the X and the Y. For the second one, it's going to give us the value of 300 and 0 for this second apple. So let's go ahead and just show this instead of talking about it. So if I run it, you'll see that I have 2 apples at the top of our screen at 100 and at 300. Pretty cool, right? And let me just show you what I mean by the object-oriented programming. If I give our second apple the player image here and I run it, you'll see that that one actually has the player image instead of the apple, just showing you a little bit about the perks of object-oriented programming. Let me revert that real quick and let's add a new method to our apple. I'm gonna create a new method here. I'm gonna go back 1 tab and I'm gonna do def move, and it's a method, so I'm setting it self. And what I'm gonna do here is I'm gonna do self.rect.y plus equals self.speed. Now, if we run this here, we actually see nothing. That's because we haven't used it yet. So let me go to the update here. And what we're going to do is we're going to simply move our apples. So I'm going to make a comment just for organizational purposes. I'll call it like apple management or something funny like that. And then what I'll do here is I'll do for apple in apples again, and then we'll just do apple.move, and you'll see that we have this little cube here. This means that it is a method. And if we press enter and then we do our parentheses here, we are actually calling this move method for both apples. And you'll see that our apples are moving, which is pretty cool. So yeah, now we have our apples moving, all nice. Now we want to do something cool. So you'll notice that in the original example, they were hitting the ground, disappearing, and then new ones were falling from the sky. So while it may seem like there's a million different apples on the screen, there were only actually 2 that I created. All I did was once they hit the ground, I just create 2 more and get rid of those old ones. And that's all I'm doing for the whole time, just looping over. There's never more than 2 on the screen. So basically what I'm doing here, what I have to do here is do a check. So remember that we have a rect for our player and we have a rect for each of our apples. And I mentioned earlier that rects are used for collisions. So we can use some built-in Python functions to check collisions. What we can do is inside of this apple for loop in our update function, we can do a check. We can do if apple.rect.collide rect, and then we do in parentheses, this will check if this apple's rect value collides with another rect value. And so which one do we want to collide with? Well, we're going to do the floor rect here. And if it does collide with this, what we'll simply do is we'll do apples.remove apple. What this is doing is saying if the apple collides with the floor, if the apple hits the floor, then remove the apple. Cool stuff. So now we can run it, go in here, it hits the floor, and it goes away. Pretty nice stuff there. Cool. But now we want them to respawn. So what we can do is we can do this. We can do apples.append, and we want to append a new apple object. So we'll do apple, and in parentheses here, we want the apple image. So apple image for the image. And then for the position, what we can do is we can do a random position. For this, we'll use the built-in Python module random. So we'll do import random at the top here. So we're importing our random. And then in the position here, we will do random.randomInt. And in the parentheses here, we want to pick a value, and I'm gonna do a little bit of padding to make it a little bit easier. But since our width is 350, I'm going to do a random int between 50 and 300 for the x, and then the y is always going to be 0 for me. I actually might do -50 so it appears a little bit off screen. And then for the speed, we will just do 3 as normal. And so now what you'll see is that if we run this, the apples fall and they hit the ground, and then 2 more pop up and they popped up right next to each other. But yeah, there you go. It's basically working pretty cool there. So yeah, nice stuff, nice stuff. But now we want to make it so that if it collides with the player, it does the exact same thing. So what we'll do here is we'll just add another check. So for this, we'll do an elif statement. And an elif basically means if this isn't true, then maybe this is true, but only if this is not true. So what we'll do is elif apple.rect.collide rect, and then we want to do player rect for this one. And if we do, for now, all we're going to do is just place the exact same code here. And now if we run it, and you'll see that if it hits the player, it will delete itself, which is pretty cool. So now we have the picking up part all working fine and dandy. Cool. So now let's add a little bit of difficulty to this, because right now they're just spawning in and moving the same speed. It's a pretty boring, endless game here. What we can do is we can send in a dynamic speed variable so we can increase the speed of these over time. What we can do is we can do this. We can create a variable here. Let's go up to our variables up here. Let's create a new variable section. I'm going to make a comment called this variables, and I'm going to do speed equals 3. And what I'll do here is I will, instead of passing in 3, this hard-coded number, I'm going to pass in speed. Of course, for this, we're going to have to access our global speed value. So I'm going to do global speed. And this is because of variable scoping. I can't really get too much into it, but basically, because this is inside of a function and we're trying to modify our speed value here, we're going to have to use the global value. Otherwise, it's going to be trying to find a local variable speed, which we don't have. Basically, if you have this variable declared outside of your function here, and it's not working, it's probably because you need to make sure that the speed you're working with is global. So basically what we're going to do with this is we're declaring this, we're using our global speed. Now we can use the speed variable easily here, and we can do one more thing. When we collide with a player, I want to increase the speed. So I'm going to do speed plus equals 0.1. Now if we run it, we can collide here, and while you don't notice it at first, I think you will start to pick up on it a bit. Let's go a little bit faster here. You can see they're going a bit faster, and every time you pick it up, it's incrementing by 0.1, and now it's getting pretty fast because it's incrementing every single time you pick it up. So now it's getting really difficult. So now we have some added difficulty to our game. All right, so now let's add a score to keep track of our score here. For this, we're going to be using the Pygame font. So let's go ahead and make a new section for this. I'm just going to put mine below where the apples are. I'm going to put a comment here, and I'm going to call this our fonts. And then I'm going to do font equals pygame.font.font, which is creating a new object, a new font object. And the first argument that it needs is the file argument here. Ours is called pixeloidmono.ttf. So I'm going to do it's a string value. So I'm going to do in quotes, pixeloid, it is case sensitive, mono.ttf, and make sure actually it is it's in the assets folder. So assets/pixeloidmono.ttf. And then for the size, I'm going to do tile size divided by 2. So it's going to be 16 pixels for each character. So now we have a font. Now let's display our font. So we're going to do this in the draw, and we want to display our font on top of everything. So I'm going to put it at the very bottom of our draw function. And what I'm going to do here is I'm going to do score text equals font.render. And this is going to, if you hover over this method here, so you can see that the arrow is pointing to a surface, meaning that this method returns a surface. So the score text will be equal to a surface value. So knowing that, we can actually create this. So it takes in for the first value the text you want it to be. So for this, we're going to use what's known as a f string. So you do f quotes, and this is a string that allows you to easily pass in variables. So I'm going to do this, and I'm going to do f string, and then do score colon space, and then do brackets inside of here. And inside these brackets, we can put a variable. And so I haven't yet declared the variable. Let's go ahead and put it up in our variable section. I'm going to do score equals 0. Scroll back down. In this parentheses, I'm going to do score here, which is pretty cool. And we don't have to declare score as global here because we are not actually manipulating it. The next argument here is we're going to do the anti-aliasing. I'm going to put true, and the color I'm going to put as white. But now we actually have to draw this because this score text is just like any other surface where we have it, but we need to actually physically draw it. So what we're going to do is we're going to do screen.blitz, and I'm going to do score text, and then I'm just going to do it in the top left. So I guess let's do 5.5. Why not? Then let's go ahead and run this here. Whoops. Float object cannot be interpreted. Oh yeah. Instead of doing tile size divided by 2, we have to actually floor divided by 2. This is because pygame.font.font only takes integer values for sizes, and the tile size divided by 2 returned a float. If you do floor divide, it will just truncate it down, which means that it'll just always round it down to the nearest integer. So that's pretty useful stuff. Now if we run it, you'll see that we have a score, although it's doing nothing right now. And the reason is because we haven't connected it to anything. So let's go ahead and make this score actually useful. Alright, so for this, what we're going to do is we're simply going to go to wherever we collide with our player, which is whenever we are actually picking up something, and all we'll do is we'll just do score plus equals 1. And since we're using the score variable directly inside of our font.render, if we press run here and we go and we click, whoops, we do actually need to use the global score inside of our update because we are actually manipulating it. So we will go up here and we'll do global score because we are actually changing the value. So now we can run it and we can pick up stuff, and you can see that our score value is updating. So there you go. And that's pretty much most of the game. The last thing to do is just to add the sound effects. So let's go here, let's exit out, and we will add our sound effects. Pretty easy stuff to do. All we have to do is just create a new sound. So let's go down here and let's do sound effects. And what we'll do here is we will do, I guess, pickup equals pygame.mixer.sound. All right. And this takes in the file argument. And for this, we're going to do the powerup.mp3 that I gave, and it's also inside of the assets folder. So assets/powerup.mp3. And one thing, I'm going to lower the volume because it's really loud. So pickup.set volume here. And this, you just set it to a value between 0 and 1. I'm going to do 0.1. Maybe my ears are just weak or something, but this will set the volume so it's a lot quieter. Then all we have to do is whenever we collect one, all we want to do is we want to do pickup.play, and that is it. Now we just run our code here, go along, and there you go. We have our cool sound effects. Cool. So that is the entire game. Cool stuff. All right, so now where to move forward with this? What you can do is you can add things like a barrier where your player can't just walk off screen. You can add different types of objects. You can add all sorts of different things. You can add a start menu, an exit menu, a restart menu, like health bars, all that sort of stuff. I challenge you to figure this out on your own. I challenge you can use things like ChatGPT to help you with learning concepts. But yeah, I think this should give you a pretty good base for learning game development and learning just coding in general here. I should have covered pretty much all of these concepts here relatively well, hopefully. Of course, leave me reviews in the comments, but I think this is pretty decent for one video. With that being said, if you have any questions, just message me in my Discord server. Go ahead and join that. It's for all sorts of things programming, and you can consider supporting me on Patreon so I can continue making videos like these. Thank you very much for watching. Have a good day. See ya.